Hello, good morning. I am Dr.A.K.Sinha. Today I am going to discuss new chapter, states of matter. And last class I have finished chemical bonding completely. I finished chemical bonding, and today I am going to start new chapter, states of matter. Here till date I have discussed about the single particles of matter, such as atomic size, ionization enthalpy, electronic charge density, molecular shape and polarity. All are related to the single particle. These properties are related to single particle. But most of the observable characteristics of chemical system which we are knowing, we are familiar, represent bulk properties of matter. Bulk properties means the properties associated with a collection of large number of atoms, ions or molecules. For example, an individual molecule of a liquid does not boil. Individual molecule of a liquid does not boil, but the bulk boils. Collection of water molecules have wetting properties. Individual molecule do not wet. Water can exist as ice, which is a solid. It can exist as liquid, or it can exist in the gaseous state as water vapor or steam. Physical properties of ice, water and steams are very different. In all the three states of water, chemical composition of water remains the same, that is the H2O. For the solid also H2O, for the liquid also H2O, and for gaseous or vapor also H2O. Characteristics of the three states of matter. Characteristics of the three states of water depend on the energies of molecules and on the manner in which water molecules aggregate. Same is true for the other substances. Here you should understand that single atom or molecule we are not single molecule or water molecules we are not using in our life. Always we are using collection, aggregate, bulk. That's why their properties we should know. What are their properties? You know that atom does not exist. Always it will exist in the form of combined state. Correct? Like that way, any single atom, ion, molecule is not very useful. What is useful? Then collection of molecules, collection of atoms, aggregate or bulk molecules, they have different properties than single. That's why we are interested to know the characteristic of the matter collectively. This is very, very important things. Chemical properties of a substance do not change with the change of its physical state, but rate of chemical reaction depend. Rate of chemical reaction depend upon the physical state. This is important, very, very important. Many times in calculation, while dealing with data of experiments, we require knowledge of the state of matter, whether it is liquid, solid or gas. We require knowledge of the state of matter. Therefore, it becomes necessary for us or for chemists to know the physical laws which govern the behavior of matter in different states. Here we will study three physical states of matter, particularly liquid and gas. Solid also we will study. Okay, that we will focus here more for liquid and gaseous states. It is necessary to understand the nature of intermolecular forces. As for example, I will discuss nature of intermolecular forces, but three things now we have to understand. First things, nature of intermolecular forces. Second things, molecular interaction. And third things, effect of thermal energy on the motion. These three things is very, very important to understand the states of matter. Three things. What are that three things? First things, nature of intermolecular forces. Second things, molecular interactions. And third things, effect of thermal energy on the motion of particles. Why these three things are necessary? Because a balance between these three determines the state of a substance or a state of a matters. Okay. Now one by one I will discuss. Now I am going to discuss intermolecular forces. Just first I will give brief idea. Intermolecular forces are the forces of attraction and repulsion between interacting particles like atoms and molecules. This term does not include electrostatic forces that exist between the two oppositely charged ions. Like you can tell ionic bond or electrovalent bond. That is different. And second things, chemical bond. These two things are not coming under intermolecular forces. Okay. This term does not include, means intermolecular forces does not include two things, ionic bond or you can tell electrostatic force. Ionic bond is electrostatic force. And second things, covalent bond. These two does not include. Question is asked. Now I am going ahead. Attractive intermolecular forces are known as van der Waals forces. Question is asked. What is the van der Waals forces? Then attractive intermolecular forces are known as van der Waals forces in honor of Dutch scientist Johannes van der Waals, who explained the deviation of real gases from the ideal behavior through these forces. So, the ideal gases is different, real gases is different. Then why real gases deviate from ideal gases? Then this can be understood by the van der Waals forces. He explained why real gases deviate from the ideal gases. Here we will discuss van der Waals forces. Van der Waals forces vary considerably, means change. Van der Waals forces vary considerably in magnitude and include, now understand what it includes, and includes dispersion forces first, also called London forces. This is the first. Second, dipole forces. And third, induced dipole forces. These three comes under the van der Waals forces. Fourth one is also there. That is the part of the dipole. That is, what is that? That is the hydrogen bond. Okay. A particularly strong type of dipole interaction is hydrogen bonding. Okay. Only a few elements can participate in hydrogen bond formation. Therefore, it is treated as a separate category. Then this hydrogen bond comes under the dipole forces. Okay. Then total these three type of forces comes under the van der Waals forces. Students will be always confused. Now I am telling you under the van der Waals forces that these three type of forces comes. First, that is the dispersion forces or London forces. Second, dipole forces. And third, induced dipole forces. Okay, these forces and a particularly strong type of dipole interaction, that is called hydrogen bonding. That also comes under the van der Waals forces, but that is coming under the dipole. Hence only three type of forces are there. But question is asked for the hydrogen bonding. Then hydrogen bonding also comes under the van der Waals forces. Then a particularly strong type of dipole interaction is hydrogen bonding. Only a few elements can participate in hydrogen bond formation. Therefore, it is treated as a separate category. Here we should know one important point. At this point, it is important to note that attractive forces between an ion and a dipole are known as ion dipole forces, and these are not van der Waals forces. Again question is asked. Here you should know at this point it is important to note that attractive forces between ion and a dipole, forces between ion and dipole are known as ion dipole force, and these are not van der Waals forces, not coming under what? Van der Waals forces. Okay. Now this different type of van der Waals forces I will discuss in the next class. Today I am stopping only here. Thank you.